Now, as we know what exactly rational numbers are now, let's check how to add rational numbers, very important. Before that, I'd like to ask you one thing, like, are natural numbers, let's say 1, 2, 3, 4, 5, 6, are these guys rational numbers? Think about it. Can I write 3 as 3 by 1? Yes, it looks like P by Q. In fact, even natural numbers are rational numbers. Can I say integers are also rational numbers? Check it out. Let's say -3, -4, -5, or positive and negative numbers are integers. Now, can I write -4 as -4 divided by 1, and which actually looks like P by Q, and P and Q both are integers? Possible. So I can say natural numbers are actually rational numbers, and whole numbers are also rational numbers, and integers are also rational numbers. And but the only idea is the denominator, the Q, should not be equal to 0. That's all about it. Now, let's go ahead and see how to add rational numbers. Before I can teach you how to add rational numbers, you guys should know something about LCMs and how to actually add fractions. Right, so let's go at this. Now, listen to this carefully, it's very interesting. Now, if I have half, or a half, it's all about I have one cake and I divide it in 2 parts. And this part is called as half, and this part is called as half. If I add them, let's say half plus half is what? Common sense. We divided 1 into half and half, and if you add half and half, it should get 1. That's all about it. Now, what is the procedure of adding this thing is, like if I see the denominator to be same, okay, it's 2 and 2, and I'll take the LCM to be 2, I'll just write 2 ones and add the numerator, that is 1 plus 1. That becomes 2 over 2, that is 1. Okay, that's common sense. Let's talk about this. I have one cake and I'm dividing it into 3 parts, and what is every part called? It's 1 by 3, 1 over 3, and 1 over 3. Now, if I add 1 by 3 plus 1 by 3 plus 1 by 3, so I should get logically 1, isn't it? Now, what is the procedure? If I have 3, 3, 3, it is same. Denominators are same, so I just write 1s and I add the numerator. There is 1 plus 1 plus 1, that goes like 3 by 3, which is 1 again. Now, these situations are easy because denominators are same, right? Now, what if I have another problem? Let's say 2 by 3 plus 5 by 3. In this case also, I can see 3 is common for both of them. It's same. So the LCM is 3. Write 3 once only and add the numerator. That is 2 plus 5. That is 7 by 3. That's how I add 2 fractions. The good condition is, if at all the denominators are same, I just have to write it once and add the numerators. That's the logic, okay? So basically, the whole addition or subtraction of rational numbers works on the denominator. If both the denominators are same, you can just add the numerators or subtract them. Now, the problem is like, if at all I have, let's say 2 by 3 and plus 5 by 4. Now, I don't see that 3 and 4 are same. Let's take this guy as, let's say it is 12. Okay, 12, 2 by 12 and 5 by 4. I can see that they're not same, right? So I cannot add 12 plus 4, or I have to take LCM. Is there any shortcut? I just have to see one thing, right? If I can see that I can make this guy 12, so can I multiply this with 3 and 3 here? See, this doesn't change the whole question. 3 cancels out to give me 5 by 4 itself. Now, that's legal in maths. If I multiply something and divide by the same thing, it doesn't change my question. So if I do that, my question will become 2 over 12 plus 15 over 12 again. So I'm just multiplying this with 3 and dividing by 3. Now I see something nice. Denominators are same. So can I write them once? Yes. And add these two guys, that is 17 by 12. That's your answer. Very simple. So now we learned, if at all the denominators are same, it is easy, just write ones and add them. If they're not same, make them same. Very simple, by either multiplying one of them with another number, multiplying and dividing here, so that these two guys should become same. That's all about it. Now sometimes you may not be able to do this. Let's say a problem like this, where you have two denominators but you cannot make them equal. Let's say you have 5 by 3 and let's say 7 by 4. Can I multiply something with 3 so that it becomes 4? No, I don't have a number like that, right? So now, what to do? A good deal is to take the LCM of 3 and 4. You should have learned this in lower classes. I'll go with 2. It doesn't cancel, so write it as 2 times and 2, 3 and 1, and this is 3, 1 and 1. Okay, this is the LCM. That is 2 and 2, 4 and 3 is 12. It means 12 is the least common multiple of these two guys. Alright? So now, anyway, I get this. We'll talk about LCMs later if you already have this in your syllabus. Now, right now I have 12. Can I make this guy 12? Yeah, that's the whole idea. Can I make this guy 12? Into 4, into 4. Right? So 3 into 4 is 12. Good enough. Can I make this guy 12? Yes, into 3, into 3. That's the logic. Now I can see that the problem becomes 20 by 12 plus 21 by 12. Now I can still see that the denominators are the same. Now can I add this? Where is it? So I write 12 once, 20 plus 21. That becomes 41 by 12. Okay, all the places, there's one logic we follow that make the denominators same and add the numerators. That's all about it. That's how we add fractions or subtract fractions or rational numbers. I hope you understand this. We need to work with a couple of more shortcuts. We'll see them later, but right now we know how to add and subtract rational numbers. Now, let's talk more about those operations of whether rational numbers are closed under addition or not. Right, so let me take two rational numbers. So they are looking like p by q, so I'll take 3 by 5 and another guy, let's say 5 by 8. These are the two rational numbers I'm taking. Right? Now if I add these two rational numbers, will I get a rational number or not? This is what I'm looking for now. Right? So I'm talking about the operation addition. So I'll take a as 3 by 5 plus 5 by 8. Now I know the trick how to add them, right? These guys are not same. And I cannot make 8 as 5 or 5 as 8 so directly, so I need to take the LCM. I should go with 2, 4 times and 2, 2 times and 2, 1 time and 5 is 1 time, so 8 into 5 is 40. 40 LCM. Can I make this guy 40? Yes, 5 into 8 is 40 into 8. Can I make this guy 40 into 5 into 5? So the problem will become 8 here, right? 24 by 40 plus 25 by 40. Now can I add this? Yes, 40 is the thing I should write once and add these two guys. That's simply 49, right? So 49 over 40. And is this guy looking like p by q? Yes, and is p like an integer? 49 is an integer, it's positive number, and q, that is 40, is again an integer. This guy is basically a rational number. Now I can say I take any two rational numbers, we add them, and we'll just learn how to add them. If I add them, the answer is again a rational number. So I can say rational numbers are closed under addition. Similarly, I talk about subtraction into the same thing. Let me take the same example. In fact, if I take the same example, I'll take 3 by 5 subtracted from 5 by 8. Right? So what's the LCM again? I just want it to be 40. So I can make it as 8 into 8 and into 5 into 5 so that I can make this guy same. So that is how much? 24 by 40 minus 25 by 40. And how do I subtract? Just write 40 once and subtract 24 minus 25. That is minus 1 by 40 is what I have. Is that looking like p by q? Yes, it is p by q. Where p is minus 1 and q is 40. And both these guys are integers. Integer basically positive and negative numbers, yes. Now I can say if I subtract two rational numbers, I am getting a rational number. So I can say rational numbers are closed under subtraction also. Now, what about multiplication? How do I multiply rational numbers? Let's talk about this. Now we understand how to add and subtract by taking the LCM. And the shortcut we learned is just make the denominators same. Right? By multiplying and dividing and just add the numerators. That's all about it. What about multiplication now? Let's talk about another set of rational numbers. When I have p by q, I'm taking two numbers, let's say 2 by 5 and let's say 6 by 13. Okay? I got to multiply them. So 2 by 5 into 6 by 13 is what I want. Now are they LCMs into multiplication? No. It's very easy. Just multiply this guy and this guy directly. So 2 into 6 is 12. 5 into 13 is 65, and that's all about it. And is this not looking like p by q? Yes, very simple. Multiplication is easy here. Just multiply the numerators and the denominators. What if one of the numbers is like this? Let's say I have 4. I'm taking a as 4 and b as 2 by 5. Do you think 4 is a rational number? Yes. It can be written as 4 by 1. Where is it? Right? Now in this case, if I add of a multiply them, A into B, that is like 4 by 1 into 2 by 5. So I can see 4 into 2 is 8 and 1 into 5 is 5 itself, and this guy is looking like P by Q again. Yes. So I can multiply two rational numbers, and all the time I'm getting the answer as rational number only. So again I can say rational numbers are closed under multiplication also. So they close in addition, they close in subtraction, they close under multiplication also. What about division? Let's talk about it. Okay. There's one problem with division again. If at all I have A, okay, 2 by 5 divided by 6 by 13, let's say I need to do this. How would I do this? In fact, one procedure is 2 by 5 into, I can make division as into, but I need to take a reciprocal of this, that is 13 by 6. Reverse this guy, or reciprocate this guy. So now it becomes regular multiplication. 2 and 13 is 26 by 5 and 6 is 13. Okay, that's all about it. And this guy I can see is a rational number. But is it always a rational number? That's the question. Look at this. I know that even 0 belongs to rational numbers, isn't it? Yes. 0 do belong to rational numbers because I can write it as 0 by 1. Okay, let's talk about one more argument here. If I say I'm giving one chocolate to 0 people, this is absurd because I'm giving one to someone who doesn't exist. This is like not defined, right? Now, is this defined that I'm giving 0 chocolates to one person? Yes. Let's say I'm giving you one chocolate. I'm giving you one chocolate. So you got one chocolate. Let's say I'm giving you 0 chocolates. It means what did you get? Nothing. You got 0. So 0 by 1 is again 0. This is sensible, but this is not sensible, right? So is 0 a rational number? Yes. 0 by 1, which looks like P by Q, where P and Q both are integers. 0 is an integer, 1 is an integer. So 0 is a rational number, right? Okay. Come back to this. Now if I divide two rational numbers, let's talk about the second guy is 0 now. So that 2 by 5 divided by 0. This guy is interesting. So what happens to this guy? 2 by 5 into 1 by 0. So I'm giving 1 to 0 people. This itself is not defined. So something which is not defined into anything is not defined. So this is not happening. Correct? It's not defined. So I can say division is always not happening in rational numbers. So I can say numbers are not close under division just because of this guy called 0. When it comes in the denominator, it basically confuses because I'm giving so many things to 0 people. I'm still giving, but where is it going? That's the whole point, right? So we understand the uncertainty or not defined property of anything divided by 0. So that's why I can say division cannot be, or rational numbers are not close on division. I hope you understand this. Let's see more videos about rational numbers.